The rational root theorem. The rational root theorem says, let's have a polynomial function p of x, where p of x equals a sub n times x to the n, plus a sub n minus 1 times x to the n minus 1, plus and so on, down to a sub 1 times x, plus a sub 0. Let that be a polynomial function with integer coefficients. Then possible roots of p of x equal to 0 have the conditions that integer roots must be factors of the constant term a sub 0, and rational roots must be of the form p over q, where p is an integer factor of a sub 0, which is the constant term, and q is an integer factor of a sub n, which is the leading coefficient. Let's look at an example. Let's find the rational roots of 15x cubed minus 32x squared plus 3x plus 2 equals 0. Then first, the factors of the constant term 2 are plus or minus 1 and plus or minus 2. These are the p's. Then the q's are going to be the factors of the leading coefficient 15. And those are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So now we need to look at all the different combinations of 1 divided by 2, of the factors in 1 divided by the factors in 2. So we could have positive 1 over positive 1, negative 1 over positive 1, positive 1 over negative 1, negative 1 over negative 1, positive 1 over positive 3, negative 1 over positive 3. Positive 1 over negative 3, negative 1 over negative 3. Positive 1 over positive 5, negative 1 over positive 5. Positive 1 over negative 5, negative 1 over negative 5. Positive 1 over positive 15, negative 1 over positive 15. Positive 1 over negative 15, negative 1 over negative 15. Halfway there. Positive 2 over positive 1, negative 2 over positive 1. Positive 2 over negative 1, negative 2 over negative 1. Positive 2 over positive 3, negative 2 over positive 3. Positive 2 over negative 3, negative 2 over negative 3. Positive 2 over positive 5, negative 2 over positive 5. Positive 2 over negative 5, negative 2 over negative 5. Positive 2 over positive 15, negative 2 over positive 15. Positive 2 over negative 15, and negative 2 over negative 15. Okay, so simplifying these, we get 1, negative 1, negative 1, 1, 1/3, negative 1/3, negative 1/3, 1/3, 1/5, negative 1/5, negative 1/5, 1/5, 1 over 15, negative 1 over 15, negative 1 over 15, 1 over 15, and so on. So let's look at how many are actually distinct. So we have 1, negative 1, 1/3, negative 1/3. So I'm eliminating the repeats. I have 1/5, negative 1/5. 1 over 15, negative 1 over 15. 2, negative 2. 2/3, negative 2/3. 2/5, negative 2/5. 2 over 15, and negative 2 over 15. These are the possible rational roots. Okay, so let's just list them out. Okay, so let's test the roots by substituting each one in for x to see which one made the equation true. So if we put positive 1 in, what's 15 times 1 cubed minus 32 times 1 squared plus 3 times 1 plus 2? Well, that equals negative 12, which does not equal 0. So that one doesn't work. It's not a root. Positive 1 is not a root. Let's try negative 1. 15 times negative 1 cubed minus 32 times negative 1 squared plus 3 times negative 1 plus 2, and that equals negative 48, which is also not equal to 0. So negative 1 is not a root. Let's try positive 2. So 15 times 2 cubed minus 32 times 2 squared plus 3 times 2 plus 2. That equals 0. So 2 is a root. So let's factor the polynomial using synthetic division. So we're going to divide the polynomial by 2. So the coefficients of the polynomial are 15, negative 32, 3, and 2. We'll bring down the 15. 2 times 15 is 30. Add negative 32 and 30, we get negative 2. 2 times negative 2 is negative 4. 3 plus negative 4 is negative 1. 2 times negative 1 is negative 2. Adding 2 and negative 2, we get 0. So 15x cubed minus 32x squared plus 3x plus 2 is equal to x minus 2, because 2 is a root, times 15x squared minus 2x minus 1. So we could go through and test another possible rational root, or we can factor 15x squared minus 2x minus 1. So I'm going to choose to factor to find the other rational roots. Okay, so because a is greater than 1, we'll use the x box method. So at the top of the x, we'll put 15 times negative 1, or negative 15. At the bottom of the x goes negative 2. We need numbers that multiply to negative 15 but add to negative 2. Those are negative 5 and positive 3. Let's make our box. In the top left, we put the first term, 15x squared. In the bottom right, we put the last term, negative 1. And I'll put negative 5x here and positive 3x here. In the first row, my greatest common factor is 5x. In my second row, my greatest common factor is 1. In my first column, my greatest common factor is 3x. In my second column, my greatest common factor is negative 1. So we have the factors 5x plus 1 and 3x minus 1. So the other roots are negative 1/5, and positive 1/3. Because I would set both factors equal to 0 and solve for x. So the rational roots of 15x cubed minus 32x squared plus 3x plus 2 equals 0 are 2, negative 1/5, and positive 1/3.